This is the derivative quiz that I gave out to my Calculus 1 students. 10 questions, all derivative. And if you want to try the questions first, the link will be in the description for your convenience. Here's the first one. Y is equal to sin x raised to the x power. Notice that the base right here is a function sin x, and the power is also a function x. So a good idea to take care of this is that we will take the natural log on both sides, because this way it allows us to bring the power to the front and it becomes a multiplication. And we will get ln y being equal to x times ln of sin x. So now you see, this is x times ln x, ln sin x. And now you might be worried that y is no longer isolated, but it's okay because we can just do implicit differentiation. So let's go ahead and put down d dx. And you have to keep in mind y is a function of x. So implicit differentiation, because the y is not isolated, and differentiating ln y, we get 1 over y, and then we multiply by the derivative inside. Derivative of y with respect to x, that's exactly what we're looking for. dy dx. Good. And for the right hand side, because we have a product, we are going to use the product rule. Keep the first function, and we multiply by the derivative of the second. Derivative of ln is 1 over the inside, which is sin x. But we're not done yet, because we have to use the chain rule. We look here inside. The derivative of sin x is cosine x, so multiply this by cosine x. Alright? And then the second part is we add the second function, which is ln of sin x, and multiply by the derivative of the first function. Derivative of x is just equal to 1. So that is what we have. And then to take care of this, we want to have the y by itself. We want to have the dy dx by itself. Let's multiply y on both sides so they cancel, and we will multiply the right hand side by y like this as well. So ladies and gentlemen, we get dy dx being equal to, we have the y, which is this, sin x to the x power. So let's write that down, sin x raised to the x power for the y. And then we'll just finish the rest. But you see, cosine x over sin x is cotangent x. So the first part can be rewritten as x times cotangent x. And then we add it with this, which is just ln of sin x. And that's it. This is the first answer. Okay, second question will be differentiating e to the inverse tangent of x squared. Check this out. It's just chain rule question. When we differentiate e to the whatever, you just maintain that first. So we have e to the inverse tangent, and the input stays the same, still have that. So we repeat that, and then we look at the inside and differentiate that. Differentiating inverse tangent, we will just have 1 over 1 plus whatever the inside is, and we square, and the inside here is x squared. But you maintain that, you put it inside here. And then next, we have to multiply by the derivative of the inside right here. So we multiply by 2x. So chain rule question. And lastly, we can just multiply everything together, and we will just write this as 2x on the top, with that e to the inverse tangent of x squared over 1 plus this to that power is just x to the fourth power. And with that, we are done. Okay, for the third one, we are going to differentiate x over 1 plus ln x. And this is a quotient rule question, because we have a function on the top and then another function on the bottom. So quotient rule in action. Write down f prime of x. This right here is equal to, let's go ahead and square the bottom right away. So 1 plus ln x squared. And then we keep the bottom function, so 1 plus ln x. And we multiply by the derivative of the top. Derivative of x is just 1. And then for the quotient rule, we subtract the top function, which is x, and we multiply by the derivative of the bottom. derivative of 1 is 0, derivative of ln x is 1 over x. Okay, and then we can actually clean this up a little bit. 1 times this is just that, 1 plus ln x. And this times that is just minus 1. And then over that, which is 1 plus ln x squared. And lastly, this and that cancel. So ladies and gentlemen, we have ln x over 1 plus ln x squared. Just like that. Done. Okay, for number 4, this is the equation that we have, and we want to have the second derivative, d2y dx2. And you see here, we have y squared, so the y is not isolated, but it's okay, because we can just do implicit differentiation. So look at this, let's go ahead and put down d dx. So implicit differentiation, and y is a function of x. Check this out. Differentiating 9x squared is just going to be the usual derivative, 18x to the first power. Done. For this part, differentiating y squared, we put the power to the front and then minus 1, so we have plus 2y to the first power. But y is a function of x, so multiply by the derivative of that with respect to x, and that's dy dx. And differentiate 9, we get 0, so that's what we have. Now get the first derivative by itself, move this to the other side, so we get 2y dy dx equals negative 18x. And then divide the 2x on both sides, divide the 2y on both sides, so we have dy dx equals negative 18x over 2y. We can reduce this a little bit, this is 1, this is 9. So first derivative is negative 9x over y. Pretty good, but we have to do this again. For the second derivative, we will just have to look at the first derivative and differentiate. Let me write that down again. We have dy dx, that's equal to negative 9x over y. Look at this equation, and we will differentiate this with respect to x. Okay? And we see, this is why the notation is d2, because you have dd, so d2. So the second derivative, and then the y, and then dx, we have the dx squared. The second derivative, well, to do this on the right hand side, we will have to use the quotient rule, right? We have the negative 9x over y quotient rule. So let's go ahead and square the bottom. So we have y squared, and then this is the top function. We are going to keep the bottom right here first, which is y, multiplied by the derivative of the top. Derivative of negative 9x is negative 9. Done. And then we are going to minus the top function, which is negative 9x. And then multiply by the derivative of the bottom. Derivative of y is dy dx. Derivative of y with respect to x is dy dx. And we found that earlier. So in fact, this becomes negative y with a negative 9y, and then plus 9x, and then dy dx is that, which is negative 9x over y, and then all over y squared. Okay, we have a little complex fraction. It's okay, because we can just multiply the top and bottom by y. So check this out. Multiply this and that, we get negative 9y squared, and then this times that, they cancel. Positive 9 times negative 9 is negative 81, and then x squared, and the bottom here is y to the third power. Okay, it looks like we are done, but in fact we can do better, because if you look at the top right here, we have negative 9 and then negative 81. We can factor out a negative 9, so let me put that down right here. And when we do that, inside here we will just get y squared, and it becomes a plus, because originally it was negative. We factor out a negative. Negative 81 divided by negative 9, so you get positive 9, and then you have the x squared. So this is what we have. And do we see it? Check this out. Right here, we do have this negative 9 in the front, but this part, y squared plus 9x squared, y squared plus 9x squared is actually just equal to 9, which is a very nice reduction, right? It's just equal to 9 right here. So we multiply by 9 over y to the third power. Multiply this out, ladies and gentlemen, we get negative 81 over y to the third power. So this is the answer for the second derivative. Okay, for number 5, we are going to get the second derivative for e to the negative x squared. So here we go. Let's put down f prime of x for the first derivative. Well, whenever we differentiate e to the whatever, this part repeats, so we will have e to the negative x squared. And then next, we have to use the chain rule. Look here at the inside. Differentiate this, we get negative 2x. So we multiply by that, and let's just put that in the front. So we have the negative 2x right here. And that's the first derivative. Then we do this again, f double prime. Take this to be the first function, and this being the second function, we will have to use the product rule. Keep the first function, which is negative 2x, and we multiply by the derivative of the second. Derivative of e to this power is just e to the negative x squared, and again, we will have to use the chain rule, multiply by this derivative, which is negative 2x. And then we add the second function, which is e to the negative x squared, and we multiply by the derivative of the first. And that will give us negative 2. Okay, let's clean things up a little bit. We see we can factor out e to the negative x squared. This times that is 4x squared. And then I will just put this with minus 2, and then put the e to the negative x squared at the end. This right here is a second derivative. Alright, here we'll be differentiating square root of x plus square root of y is equal to 1. Notice that the y is inside of the square root, y is not isolated, so we can just do implicit. Okay, for number 6, we'll be differentiating square root of x plus square root of y is equal to 1. And because the y is inside of the square root, because the y is not isolated, so we are going to use implicit differentiation. Meaning that we look at this and then just put down d dx and then get to work. Differentiating square root of x, we get 1 over 2 square root of x, and then that's it. Well, should we use chain rule? Technically, yes, but does it matter? No, because the derivative inside is just 1. But for this right here though, differentiating square root of y, we get 1 over 2 square root of y, but we will have to use the chain rule, because the derivative of y is precisely what we want, and that's dy dx. Derivative of y with respect to x. And that's equal to the derivative of 1, which is 0. Now just clean things up. Move this to the other side, so we get 1 over 2 square root of y with dy dx being equal to negative 1 over 2 square root of x. And then multiply this to here, so we get dy dx being equal to negative 2 square root of y over 2 square root of x. Lastly, we see that this and that can cancel, so ladies and gentlemen, we just get negative square root of y over square root of x. And then we are done. Alright, number 7, we will be differentiating cosine x times tangent x. For this one, before we use the product rule, can we simplify this? Yes, because you should recognize that tangent x is just sine over cosine. So, here's the deal. We are going to rewrite this as cosine x times sine x over cosine x. Because if we do it this way, you see, this and that cancel. So in fact, the function is just simply equal to sine x. But this is not the answer though. We still have to do the derivative. So when we differentiate this function, we get cosine x. And that will do it. Okay, number 8, we will be differentiating secant of x to the third power. So this is just pretty much a straightforward chain rule question. Here we go. Y prime is equal to, first, you have to remember the derivative of secant. And the derivative of secant is secant of the inside times tangent of the same inside. The inside here is x to the third power. So we will get secant of x to the third power and then times tangent of the same inside stays the same, like this. And then we use the chain rule. We multiply by the derivative of this, which is going to give us 3x squared. And that's it. And in the end, we can just put this at the front. So we have 3x squared times secant of x to the third power times tangent of x to the third power. Okay, number 9, we'll be differentiating square root of x over 1 plus x squared. And this right here, we will just use the quotient rule because it has a quotient. So here we go. Let's go ahead and square the bottom right away. So we have 1 plus x squared, and then we square that. And for the top, we keep the bottom function first, which is 1 plus x squared, and then we multiply by the derivative of the top. And the derivative of square root of x is 1 over 2 square root of x. And then we minus the top function, which is square root of x, and we multiply by the derivative of the bottom. The derivative of this is just 2x. So that's pretty much it for the calculus part. And then to simplify this, we see that we have a little complex fraction, it's this part. So let's go ahead and multiply the top and bottom by this denominator, which is 2 square root of x. And of course, do the same on the bottom. So check this out. When we take this times that, 2 square root of x cancel, so we just have that. So this is equal to 1 plus x squared. And then next, we take this times this. Be really careful though. I will write down everything for you guys. Square root of x times 2x, right, times 2x. And then at the end here, we multiply by 2 square root of x. Firstly, 2 times 2, we can work that out, that's just equal to 4. Good. But when we have this times this, that's another x. That's just x, right? So this right here is just x. And x times x, so we get 4x squared, right? So when we take this times that, we will get minus 4x squared. Right, so have a look on that. And lastly, we'll just put the bottom right here. Perhaps I'll write this down first. 2 square root of x times 1 plus x squared and then square. And we see this and that can be combined, so we will combine them. 1 minus 3x squared over 2 square root of x times 1 plus x squared, and then we square that, and with that, we are done. Last question. We will differentiate ln of x squared over x to the third power plus 4. Well, we see that we have this fraction inside of the ln. So in fact, before we do calculus, we can do some algebra first. So we'll break it apart. It's just ln of the top, which is x squared, and then minus ln of the bottom. So ln of x to the third power plus 4. And we can do a little bit more. Right here, we can bring the power to the front. So we get 2 ln x, and then minus ln of x to the third power plus 4. And now we are ready to differentiate f prime of x. Here we go. Differentiating a constant multiple with a function is just 2 times the derivative of that, which is just going to be 2 over x. Okay? And then differentiating this, we get minus, well, ln, the derivative for that is just the inside will go on the bottom, so that's x to the third power plus 4. But you know it, we will have to use the chain rule, multiply by the derivative inside, and that will give us 3x squared. So this is it for the calculus part, and at the end we'll just combine the fractions. So let me multiply this by x to the third power plus 4, and also do the same on the top. And let me multiply this by x, so they have the same denominator. Alright, let's see, we are going to get this times that, 2x to the third power, and then 2 times that is plus 8, and then minus this times that, which is 3x to the third power, and over the same denominator, so x times x to the third power plus 4. Finally, ladies and gentlemen, this and that can be combined. So we will get, let me see how I wrote down the answer. Okay, we have the negative, right? This and that is negative x to a third power. That's how I wrote down the answer. And then plus 8 over x times x to a third power plus 4. Right? That's it. There you have it. So hopefully this right here helps, especially if you're taking Cal 1. This right here shall provide you with some derivative exercise. I have tons of videos on derivatives, so if you guys need help, check out my playlist over there. See you guys over there. That's it.